All right, so this is part two of the homework, and I'm going to be explaining the code over here. Um, so these are all this is the hardware register base where the GPIO, MMIO are all start from. So this is the base address. This is a span, which is around 64 megabytes, and this is the register mask for that, and this is the mask for the push button. If we scroll down here, this part is basically setting up the virtual address in memory. And over here, what we see is for the timer, I'm using the Core M9. Which one was it again? I believe it is the, yeah, ARM A9 MP core timers. And the base address is this, so it's 0x triple F EC0. So I've basically added this to the virtual base address. Uh, Now using this uh, variable, I'm able to access the the A9 timer, which what is it called? The MP core. Let me see that again. It is the ARM A9 MP core timers. Yeah, with this as the base address. And if we scroll down, what essentially I've done is for the 7-segment display. Um, these are the base addresses for the 7-segment display, each one of them. This one is um, this one we get from the hps0.h file, which we generated using QSys. Um, Also, I've started my initial time at 3,480 seconds, which is like 58 minutes. So this is 58 minutes. And then I have also put uh, 3 additional start times from 0 seconds, and this is around 59 minutes, and this is all the way down to 24 hours to 59 minutes. Yeah, 24 hours, 59 minutes, yes. So this is just to show when I'm prototyping it or essentially displaying it on the 7-segment display. I want to show that it for 0, it goes up by a minute, and then when we reach 59 minutes and then goes up by a minute, it wraps up to an hour, and essentially when it reaches 24 hours, it resets back to 0 seconds. Okay, so again, this is the base address for the timer, essentially. Um, let's go to the next, and this one essentially defines how the uh, basic these are the LEDs on the 7-segment display. How are they going to be activated for 0, 1, 2, 3, 4, all the way to 9? And this is a counter value that will be loaded into the register. So if I can pull this up we here, yes, okay. So we need to load essentially I think two 200 million cycles into this register. So basically, whatever we load over here will be the starting value, and then it'll count down to 0. And to extract the current value, we just read this register, which is about um, 4 bytes ahead of this. So everything is incremented by 4 bytes. So we follow that over here. So we initially set the counter. Where is it again? Yeah, over here. So if you see here, we set the count. We set that register 0xFFEC600 to the counter value, and then we want to set these bits over here, which is sorry. Yep, you want to set these bits essentially, control bits to set the mode and the, what do you say, enable. So we want to enable the timer. Um, then what we do is we create a while loop that counts for 24 hours. And essentially what we're doing is, this is to scan the button. So this is just to make sure that I want to set the initial time. When do I want the initial time? Whether it be 0 seconds, 59 minutes, or 24, close to 59 minutes, or 23 hours. I'm sorry, what is it? 23 hours, 59 minutes. Yes, correct. So it depends on that. So that's the whole thing. This is what that's doing. Then over here, I'm just waiting till the counter goes to 0. So from all the way from 200,000 cycles all the way to 0, because that is a second essentially. And I'm waiting for that. That's why it's in a while loop. And once that's reached, I increment the time by +1 second. And then using this, I can assign the hours, figure out the hours, minutes, and seconds. This is just to print to see if it works or not. This is just for debugging. Then what I do is I assign these to the PIOs. Of course, you have to invert it because, I mean, it's active low. These are sent to the addresses of the PIOs. Basically, this is connected to the 7-segment display. These are the base addresses. And we assign the bits basically to these PIOs. And finally, when it reaches essentially the last minute before 24, when it reaches 24 hours, it resets to 0. It's an infinite, so it keeps on going. It's an infinite loop. Over here, what's happening is basically, so when we read the value from, when essentially it goes from 200,000 to 0, essentially what happens is this part of the register, the interrupt status goes to 0. Yes, it goes to 0, right? So this goes to 0. So we need to clear this. Every time we count 1, we need to clear this. So that's what it's essentially doing. So over here, we check if it is 0 to know that we've completed 1 second, or whether, because it's a countdown timer from 200,000 cycles down to 0, or whether it count 1 second. And then once we're done with that, we have to reset the, what do you say, the interrupt. And that's what we're doing, and we set it to 1. And that's pretty much it. So the next video, I'll show you how it works on the Terasic board on the 7-segment display. Well, this is part 2 of the homework. And we're displaying the count up timer on the 7-segment display. So the first 2 is the hours, then the minutes and seconds. So over here, we're going to see different scenarios. So right now we have the 2-minute mark, and it should go up after a minute to 3 minutes. So we'll have to wait. Okay, so it went up by 3 minutes. Now I want to see if it wraps up to an hour, so I'll just change the time to 59 minutes or so. So I'm going to use this GPIO button, HBS button, so I'll press that. Okay, let reset it to 0, then I can click this again. Let's try that again once more. Yep, okay. So we're at 59 minutes and 5 seconds. Okay. So in about 40 seconds, it should wrap to an hour. And this should be 01. So that's 1 hour. So that's wrapped up to 1 hour. Now, in the case of now this goes up all the way to 24 and then it resets to 0. So I'll just do that. Again, I'll shift it to 24 hours. Okay. So this is 23 hours, 59 minutes, and 4 seconds. So another minute. That's it. All right. Thank you very much.